window system that's designed for what's called a heavy use commercial. It's a much more beefier system. This is also condominium. This window is in what's called a zone 5 of the building, which means it's an end zone. And if you're looking at damage and you're looking at loss, check out the corners of the building, which is called zone 5. Zone 5 takes the most amount of stress, the most amount of tension. And this is a zone 5. This is a different situation altogether. Again, cascading damage profile. Multiple damage points pointing to the same thing. Here, this is what's called a deglazed panel right there. Okay, that glass fractured in such a way where it unsat from the glazing bead. You can literally go up with your finger and press on that glass, and it's going to make a sound like popcorn. It's going to be like when you press on it. Okay, I want you to start putting your hands on these pieces of glass, putting your hands on these window systems. Get in there, because you're going to find a multitude of things. It's going to inspire you to make a lot of money. You know, really, seriously. You know. Now, it worked in such a way also where you had this rotated frame. You see this frame rotation here? You see that bending? It's a lot of pressure. This is a very high pressure rated window. And it separated what's called the interior seal, which is that drywall seal. It literally fractured it all the way around at that top corner. Another thing you see here, which I didn't mark down, but I'll point it out to you. You see the head of this screw dislodging? You see that right up there? That's called fastener distress. Okay? And this is what you're going to get a lot of times when you start pointing at screws. They're going to say, well, oh, that was just a lazy carpenter that didn't, you know, push the screw in all the way. Well, a lot of times when you're talking about fastener distress, when you back that screw out, and I don't recommend you doing that because they could say that you're tampering with stuff, but if you back that screw out and the shank of the screw is straight and the head of the screw has deflection, that's fastener distress. And also another thing to note is that if that window under pressure is moving like this, like that, the shank of that screw is digging a hole inside its resting place, much bigger than it was before, where you have to then take that screw out. You have to fill it with a special epoxy, an engineer-approved epoxy, before you can re-adhere it, right? Before you can re-adhere it to the structure, because that screw is no longer acting in the same capacity as it was before. This is important stuff to realize. And again, I'm trying to scooch us all in because I can talk forever on this, but let's go on to the next one. Okay, this is another thing. Again, you got, this is a mull bar. Anybody know what a mull bar is? Mull bar, real quick. If you have a spense in a building that's too large to cover with one fenestration product because the code won't allow it, it doesn't have the same design pressure, you've got a steel tube or an aluminum tube, depending on what they're using, which is cut and you adhere it to the opening and you put two smaller windows in its place. That's called a structural mull bar. These mull bars are also tested. You've got like a T-clip that goes on the top of that mull bar, and that mull bar gets shot up into the masonry. Well, I'm thinking of Florida, but it gets shot up into masonry, right, the poured sill, and it gets shot down into the poured sill and the poured header. Once that's seated properly, they then install the window to the mull bar and to the jambs, the side of the window. Okay, this takes structural load and it equalizes the design pressure, so you almost take that opening and you break it in two. Again, this storm was so powerful, and this is Wilma, by the way, it literally bent this structural mull bar and dislodged it, bent the screws, and also this thing took a hit from something, because I think this was probably on the third floor, but you see there's your broken glass. Your insurance company would have paid for this window because you got a break in it. But you want to know something? This is nothing compared to what this is telling us. And see this breaking along this drywall over here? This mull bar? Those windows are no longer operating with the substance that they need to. And somewhere down the road, Aunt Sadie's going to get pulled out of this window when the next storm comes by here, because it's going to literally have negative deflection. That thing's going to fly away. Let's see if we can get to the next one. This is cool. This is a sliding glass door.
Ivan,
yeah.
What kind of camera are you using?
We depends on the situation. My guys walk around with 7 megapixel cameras when they do their shots. Yeah.
I mean, is there some, because it looks almost like a macro. I mean, you're really getting in close on
Oh,
some
yeah,
of
yeah.
this stuff.
We set up the macro for close vision. What we do when you see our reports, because our reports when we come in and investigate a property are pretty substantial. We do a full view of the window, and then we have a really organized inspection process where we go through the entire window system from the adherences all the way in to the very minutia of the window, and we will photograph each part of that and video it, and we'll even set up a dance if we have to, depending on what we need to do to get that evidence to prove what it is. This sliding glass door is an interesting thing, and that's just some of the stuff I want you to keep in mind. This was a double pane operational sliding glass door, which is called, in window business, the operational sash is the X sash and the unoperational is the O sash. This is an XX door. To close one door down from opening, they put an L bracket in to keep it stable, okay? They'll put an L bracket in, and on the jamb side, which you're not going to see, they put small L brackets, and they make sure that this door doesn't close. It's a preference, okay? After they did this, this door was under such flexion due to movement, positive and negative movement, that it took this aluminum part here, this L bracket, and it just torqued it. You see that? When you see that, that's wind pressure. This is what the insurance engineer said to us when we were walking through doing the re-inspect. They said, well, that's just overuse. Someone just opened the door really hard and they were shaking it. And I said, do you mean to tell me that this 72-year-old woman in here is occupying her day opening and closing this door like hundreds of times to create a bent bracket on it? This is kind of a ridiculous thing that you guys have probably tremendous stories, but these are things I want you to look at. I want you to get into it, because when you see this, you say, okay, well, maybe there's more to it than this. Give us a call. Well, we could be at our office in Florida, and I can say, take a picture of this, 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 and this, and this, and send it to me. And we can diagnose it from Florida, and if we think there's something there to look at, we'll tell you, hey, pay attention to this, and if there's really something to look at, we'll be on a plane. We'll come out and we'll see it. Because the problem is that the insurance companies are not paying for these window claims. They're fixing roofs. They're doing all kinds of other stuff. And they for some reason, they think the wind pressure that can create uplift on a roof and put water infiltration into a building is not strong enough to damage a window system. These are the questions that we got to raise in our mind. It certainly is, because the whole system is built as an entire structure, an enclosed structure. Let's see if we can do one more. This is something else I want you to look at. This is a sliding glass door. It's we really zeroed in because I wanted to show you this. This is what is this? This is your rail. This is your side rail, your jam rail over here. At the side of the sliding glass door, I know what's going to happen. Everybody's going to go home and start looking at their windows. Happens all the time. At the side of the sliding glass door, you have what's called a marine gasket. Okay? The new doors are glued in. They're a little different. The systems work differently. These old sliders that you're going to find around here in these parts, the glass is glazed with a marine gasket. Okay? They set the glass, they put their Sikaflex into it, and then they run this gasket almost like a spleen of a screen, and they force it in there. And this thing is held under a tremendous amount of pressure. It keeps the glass seated properly in the glazing seat and allows the door to operate back and forth, lets the aluminum handle the load while the glass sits there nice and comfy. Well, what happens in a wind environment is that the rigidity of the aluminum in the rails is holding that glass still. You got this big sheet of glass, which is a sail, okay? The wind is flexing. Check out that YouTube video. You'll understand what I'm saying. That glass is flexing back and forth, back and forth. This marine gasket, okay, how am I going to do this? Okay. This marine gasket, when the glass moves, it creates a space like that. And that pressure literally sucks that marine gasket into the aluminum structure, okay? The glass then goes into negative flexion. It comes back and it locks that gasket into an ingested state. You see this here? You see the gasket also